If it fails to update automatically, we can also restart the service manually in this button next to it. If this edition is wrong or has problems during the upgrade process, we can also roll back based on this version. This is the offline function we realized. This is for master. Let's take a look at worker. Worker is actually similar, because master mainly undertake the distribution of tasks, and some tasks running that master should undertake internally. For worker there are also the most servers here. So what I mentioned earlier, we mainly offline our master first. Ensure that your service can normally distribute tasks to execute later. For offline, server for master and worker, it's actually similar. I also choose the server to update first, and then watch how our server performing the task. Is it 0 or not? Then look at its task status. It executes the final state, then look at the current version. In this version, we still support differentiated projects. That is, when the version is upgraded, the server, you cannot upgrade the new version first. And then if there is a follow-up new version is released, you can also upgrade and release across versions. So there is a case of the current version and the file name version here. The others are the same as the master management mentioned earlier. We also managed resource pools. Resource pool management uploads our upgraded version information before each upgrade, correlation time, etc. and record it in our database. Every time I upgrade, I will record which version we are currently releasing by going to the database to find the corresponding version information and the location of the corresponding upgraded overall package. Then call the Netty service from API layer and distribute it to all our servers. There may be exceptional conditions during the upgrade process. The anomaly detection mechanism is also mentioned here. It is actually relatively simple. The main purpose is to let users see the running status globally. That is, after the upgrade, you can look at the projects you have been running recently, the following workflow process status or process situation. Then start automatic detection. This is checked manually, because the historical task data of the database is still relatively large, so this piece is set to be detected manually. This is the usability enhancement part. The third part is a lightweight requirement. If lightweight is required, because our company actually has many internal systems that also need to schedule tasks. However, they have already used scheduling tools such as XXJob in the early stage, such as executing their business logic in parallel with Java, execute in a lightweight way. So we wondered if we can base on the execution characteristics of XXJob and DolphinScheduler to make it compatible. And allow users to schedule tasks. So we need XXJob compatibility. Briefly introduce the functional features of XXJob. It is mainly divided into dispatching center and actuator. In the dispatching center, it is divided into registering related services and callback services. It is mainly the request service of an ICDB encapsulated by Netty. This is different from DolphinSchedulers. DolphinScheduler is also Netty, but it is requested through our client mode. Therefore, we need to be compatible with a scheduling server of XXJob. And then when the actuator is started, it automatically registers to our dispatch center. This is the situation with XXJob.